Hello friends, this is Vinay from iOSInterview. Today we will discuss a very most important topic related to Swift initializers. So people do not know what they want until you show them. Moving on the video, this is coded by Steve Jobs. Topics we will cover on this video are importance of initialization, default initializers, member-wise initializers, designated and convenience initializers, two-phase initialization, failable initializers, required initializers, and conclusion. So why understanding initialization is important? Most of the time you will create instances of classes and structs. Proper initialization ensures that these instances are in a valid and usable state. You need to understand how to properly initialize these types, example class, struct, etc., set up their properties and define initializers. When you subclass a class, you will need to understand designated and convenience initializers to ensure that the subclass initializes both its own properties and those inherited from the superclass. Failable initializers, which can return nil, are used for error handling during initialization. This is important when dealing with situations where object creation might fail due to invalid input or other reasons. Interviewers might ask you about different types of initializers, when and why to use them, and how to handle initialization related challenges. So friends, moving on, default initializers. What is the default initializer in Swift? A default initializer is an automatically generated constructor provided by the Swift compiler for your custom data types, such as classes and structures, structs. It allows instances of your types to be created without explicitly defining an initializer. When does Swift provide a default initializer for your custom types? When you define a custom struct or class, Swift automatically generates a default initializer for you if all of the following conditions are true. All properties of the class of the type have default values. The type does not have any custom initializers defined. Default initializer with struct. So friend, this is example of default initializer with struct. Struct person var name string equal to Alex Murphy, var age int equal to 30. Creating an instance using the default initializer. Let person equal to person. Print person dot name. It will give the output Alex Murphy, and print person dot age. It will give the output of 30. In the above example, all properties have default values and no custom initializers are defined. Swift automatically generates a default initializer for the person struct. Default initializer with class. Class person var name string var age int. Creating an instance using the default initializer. Let person equal to person. Print person dot name output nil. Print person dot age output nil. In this example, name and age are declared as optionals. It means they don't have default values assigned. Swift automatically generates a default initializer for the person class. When we create an instance of the class using the default initializer, the properties are initialized to nil since optionals don't require explicit values. What are the limitations of default initializers? Customizing the behavior of a default initializer for your custom type isn't directly possible, as they generate automatically. They don't allow you to include custom initialization logic such as validation or complex setup for your properties. They are only generated when all properties of your type have default value assigned. If any property doesn't have a default value, a compilation error will be there. Class person, var name string, var age int, init. This will result in a compile error. As not all properties have default values, you would need to assign default values or provide custom initialization logic. Let person is equal to person, compile error due to lack of default values or custom initializer. When are default initializers useful? Default initializers are useful when you want to create instances with default property values without having to manually write initializers. They save you from writing repeated code and are particularly handy when your type has many properties, most of which have default values. Member-wise initializers. So friends, moving on next, member-wise initializers. What is a member-wise initializers? So friends, a member-wise initializer is an automatically generated constructor for a struct that allows you to initialize its properties by simply providing values for those properties during instance creation. It's a convenient feature to simplify the process of creating instances of a struct with named properties. When you define a struct and declare its properties, Swift automatically generates a member-wise initializer for you. This initializer takes parameters with labels that match the names of the struct's properties. For example, if you have a struct called person with properties name and age, Swift generates a member-wise initializer like this. Struct person var name string var age int. Swift generates a member-wise initializer like this person name string age int. Member-wise initializers are not automatically provided for classes. You need to write custom initializers for classes if needed. How can you customize the behavior of member-wise initializers for a struct? You can customize the behavior of member-wise initializers for a struct by providing your own custom initializers. When you define a custom initializer in your struct, it replaces the default member-wise initializer. Within the custom initializer, you can perform any custom logic needed to initialize the properties. For example, struct temperature var Celsius double init Fahrenheit double self.celsius equal to Fahrenheit minus 32.0 into 5.0 by 9.0. So friends, you can see we can initiate a custom logic with member-wise initializer. If you still want to retain the default member-wise initializer along with your custom one, you can call it explicitly from within your custom initializer using self.init. For example, struct point var x int var y int init x int y int self.x is equal to x self.y equal to y init self.init x0 y0. Can you define default values for properties in a struct with member-wise initializers? Yes, you can define default values for properties in a struct that has member-wise initializers. To assign default values to properties, you do so directly within the struct's declaration. For example, struct point var x double equal to 0.0 default value for x, var y double equal to 0.0 default value for y. Let origin equal to point creates a point instance with x equal to 0.0 and y equal to 0.0. These default values will be used when creating instances of the point struct using the member-wise initializer. This feature is particularly useful when you want to provide sensible default values for struct properties while still allowing customization through member-wise initialization. What happens if you don't provide a custom member-wise initializer for a struct with properties that have no default values? If you don't provide a custom member-wise initializer for a struct with properties that have no default values, Swift will not automatically generate a member-wise initializer for that struct. In this situation, you will have to create your own custom initializers for the struct, and it becomes your responsibility to ensure that all properties are properly initialized. Struct point var x int var y int, creating an instance without member-wise initializer. Let point equal to point. It will print error missing argument for parameters x, y in call. When you attempt to create an instance of point without an initializer, Swift will generate an error because it doesn't know how to initialize the properties x and y without explicit values being provided. To resolve this, you can either provide your own custom initializer that initializes x and y, or you can assign default values to the properties in the struct's definition. So, friends, why Swift does not provide a member-wise initializer for classes? Swift does not provide member-wise initializer for classes primarily due to the fundamental differences in the way classes and structs work. Inheritance and superclass initialization. Classes can be part of class hierarchies where inheritance is common. Superclasses may have their own custom initializers that need to be called properly during subclass initialization. Member-wise initializers may not handle this inheritance chain and superclass initializers correctly, leading to ambiguity and potential issues. Complex initialization logic. Classes can have more complex initialization logic compared to structs. They may need to acquire and release resources, perform setup, and ensure proper state before and after initialization. Member-wise initializers might not be sufficient to encapsulate all the necessary logic. Design choices. Member-wise initializers, while convenient for simple cases, might encourage less thoughtful initialization of class instances, potentially leading to unexpected behavior. Classes often require more customization and control during initialization. Swift encourages developers to define their own initializers to ensure that the initialization process aligned with the class's requirements. Designated and convenience initializers. In Swift, classes and structs can have two types of initializers, designated and initializers and convenience initializers. These serves different roles in the initialization process. What are the designated initializers? Designated initializers are the primary initializers for a class or struct. They are responsible for initializing all properties directly declared in the class or struct. Every class or struct should have at least one designated initializer. When you create a subclass, it's customary to call a designated initializer of the superclass before performing any additional setup in the subclass's designated initializer. Class person var first name string var last name string designated initializer init first name string last name string self dot first name equal to first name self dot last name equal to last name. Let John equal to person first name John last name Murphy. In this example, init first name last name is the designated initializer for the person class. It initializes both the first name and last name properties directly. What are the convenience initializers? Convenience initializers are secondary initializers. They provide an additional way to create instances, often with a subset of properties or with different parameter sets. Convenience initializers must call a designated initializer either directly or indirectly before they complete. This ensures that all properties are properly initialized. Class person var first name string var last name string designated initializer init first name string last name string self dot first name equal to first name self dot last name equal to last name. Convenience initializer convenience init full name string let components equal to full name dot split separator double quote. Calling the designated initializer self dot init first name string component dot first double question mark double quote last name string components dot last double question mark double quote. Let John Murphy equal to person full name John Murphy print John Murphy dot first name John Murphy dot last name prints John Murphy. In this example, init full name is a convenience initializer for the person class. It splits the full name into first and last names, then then calls the designated initializer to set the first name and last name properties. Can a class or struct have multiple designated initializers? A class or struct can have multiple designated initializers, each with a different set of parameters. However, it's essential that they initialize all properties declared in the class or struct. Here is an example. Class rectangle var width double var height double init width double height double self dot width equal to width self dot height equal to height init square side double self dot width equal to square side self dot height equal to square side. In this case, rectangle has two designated initializers, one for rectangles and another for squares. Explain the concept of initializer delegation in Swift. Initializer delegation refers to the process of one initializer in a class or struct calling another initializer in the same class or struct to perform part of its initialization. This is often used to avoid code duplication where setting up common properties. The designated initializer should ensure that all properties are initialized either directly or indirectly. What are the rules Swift applies for delegation calls between initializers? In Swift, there are three key rules that govern delegation calls between initializers. These rules help ensure that properties are properly initialized in a class or struct hierarchy. Rule 1. A designated initializer must call a designated initializer from its immediate superclass. When a designated initializer is defined in a class, it must call a designated initializer from its immediate superclass, the class it inherits from. This ensures that properties defined in the superclass are properly initialized before the subclass's own properties are initialized. Rule 2. A convenience initializer must call another initializer from the same class. Convenience initializers are not required to call a superclass initializer. Instead, they must call another initializer from the same class, whether it's designated or another convenience initializer. This helps to centralize initialization logic and avoid duplication. Rule 3. Initializers must ensure that all properties are initialized before an instance is considered fully initialized. Regardless of whether it's a designated or convenience initializer, the final goal is to ensure that all properties in the class or struct are properly initialized before an instance is considered fully initialized. This rule helps maintain the integrity of the instance and ensures that it's in a valid state for use. Class vehicle var wheels init wheels int self.wheels equal to wheels. Class car vehicle var color string. Rule 1. A designated initializer must call a designated initializer from its superclass. Init wheels int color string self.color equal to color super.init wheels calls the designated initializer of the superclass. Rule 2. A convenience initializer must call another initializer from the same class. Convenience init self.init wheel wheels 4 color red calls the designated initializer of the same class. Rule 1 is followed by having the designated initializer of the class call the designated initializer of its superclass vehicle. Rule 2 is followed by having the convenience initializer init call another initializer init wheels color from the same class car. Rule 3 is implicitly satisfied because the superclass's properties are initialized first due to the designated initializer of the superclass being called followed by the subclass's properties. Explain about initializer delegation using a subclass. Let's say you have a custom user profile class representing user profiles. You want to initialize a user profile with their basic information such as username and email. Class user profile var username string var email string init username string email string self.username equal to username self.email equal to email convenience init Facebook data string let username equal to Facebook data username double question mark no username let email equal to Facebook data email double question mark no email self.init username email class Facebook user profile inherited var Facebook id string var profile picture url string designated initializer for initializing with Facebook data init username string email string Facebook id string profile picture url string self dot Facebook id equal to Facebook id self dot profile picture url equal to profile picture url delegation to the designated initializer of the superclass user profile super dot init username email convenience initializer for initializing with basic information and default Facebook data convenience override init username string email string self.init username email Facebook id no Facebook id profile picture url no profile picture creating a stance of user profile let alex equal to user profile Username Alex Murphy, email alex underscore m at the rate hotmail.com. Creating instance of Facebook user profile. Let Facebook profile equal to Facebook user profile. Username Alex Murphy. Email alex underscore m at the rate hotmail.com. Facebook ID 789012. Profile picture URL http facebook.com alex.jpg. Facebook user profile provides its own designated initializer for initializing with Facebook specific data, which delegates to the designated initializer of the superclass user profile. Two-phase initialization. What is two-phase initialization in Swift? Two-phase initialization is a process where an object is initialized in two distinct phases to ensure that all of its properties are correctly initialized and that its superclass's initialization is complete before it starts initializing its own properties. What are the two phases of two-phase initialization? Phase 1. This phase is responsible for initializing the class's properties up to and including those defined in the current class. It starts from the root class and moves down to the moves down the class hierarchy. Phase 2. This phase is responsible for custom initialization logic and may involve initializing properties, calling methods, or performing any additional setup after phase 1. What happens if you try to access an instance property in phase 1 of initialization? In the below example, trying to access the value property before initializing it within the init method result in a compile time error. Swift enforces that properties must be initialized before they are accessed to prevent unpredictable behavior. Class, my class, var value int, init, attempting to access value before initializing it, print value is value error, self used before all properties are initialized, value equal to 16, let my object equal to my class. Failable initializers. What is a failable initializer in Swift? A failable initializer is a initializer that can return an instance of the class struct or enum, or it can return nil if initialization fails. It is declared with the init question mark keyword, indicating its potential for failure. When should you use a failable initializer? Failable initializers are useful when you need to create an instance conditionally and cannot guarantee that initialization will always succeed. Common use cases include parsing data from external source, example JSON, where the data may not be well formed or when specific requirements must be met for an instance to be created. The return type of a failable initializer is optional. It can either return an instance of the type if initialization succeeds or nil if initialization fails. Provide an example of a failable initializer for a custom type. To define a failable initializer, you declare it with init question mark and within the initializer you perform validation and checks. If the initialization conditions are not met, you return nil. Is an example. Struct user var name string var age int init question mark name string age int guard age greater than equal to 0 else return nil. Age cannot be negative. Self dot name equal to name self dot age equal to age. Let alex equal to user name alex age minus 5 print alex output nil. Required initializers. What is a required initializer in Swift? A required initializer is a special type of designated initializer in Swift. It used in classes and indicates that all subclasses must implement this behavior. Subclasses are required to provide their own implementation of the required initializer. Why would you use a required initializer in a class? You would use a required initializer in a class when you want to ensure that all subclasses provide a specific initialization behavior. It enforces a contract that guarantees certain properties or setups must be performed during initialization. Provide an example of a required initializer in Swift. Let's say you are working on a weather app and you have a base class called weather data that represents weather data. You want to enforce that every subclass of weather data provides a required initializer for initializing common properties like temperature and condition. Class weather data var temperature double var condition string. A required initializer for common weather data required init temperature double condition string. Self dot temperature equal to temperature. Self dot condition equal to condition. Class daily weather data inherited weather data var date required init temperature double condition string self dot date equal to date super dot init temperature condition init date temperature double condition string self dot date equal to date super dot init temperature condition class hourly weather data inherited weather data var time string required init temperature double condition string self dot time equal to now super dot init temperature condition init time string temperature double condition string self dot time equal to time super dot init temperature condition weather data has a required initializer init temperature condition that ensures any subclass must provide temperature and condition data during initialization. By using a required initializer, in this scenario, you ensure that all subclasses of weather data adhere to the contract of providing temperature and condition data during initialization, which is essential for maintaining data integrity in your weather app. What happens if a subclass doesn't provide an implementation of a required initializer? If a subclass doesn't provide an implementation of a required initializer, the Swift compiler will generate an error. This enforces that all subclasses adhere to the contract specified by the required initializer. Conclusion. So friend, in this video, we tried to cover all possible questions based on Swift initializers. This will definitely help you to prepare for your next interview. Thank you for watching this video. Please comment below if you want download link for this PPT. So I will provide it on description box. So friends, thank you for watching this video. Please like, share and subscribe my channel for getting such type information video related iOS interview. Thank you.